All right, welcome to this explainer. Today, we are tearing down the exact marking framework for Cambridge AS and A-level mathematics. Specifically, we're zooming right in on topic 2.3, trigonometry double angle formulae. We're not just crunching the math here, okay? We're conducting a full elite examiner's audit, so you can see this exact topic directly through the eyes of the people actually grading your paper. Let's dive right in.
Now look at this. It's honestly fascinating how Cambridge frames this specific topic. As one senior examiner pointed out, the literal difference between sitting at a B and securing that A star often boils right down to how well you understand double angle formula. They don't just see this as another math problem on the page. No, to them, it's the ultimate dividing line between your average candidate and top-tier talent. You might be wondering why. Well, because these questions demand complex, multi-stage analysis. You've got to navigate this tricky sequence of algebraic manipulation, and that instantly separates the students who truly grasp the underlying logic from the ones who are, just crossing their fingers and hoping for the best.
So how do we secure that elite grade? You absolutely have to master what we call the method mark strategy. Look, method marks are given for showing the correct procedural and analytical process, even if your final numerical answer is completely off because of some tiny arithmetic slip-up. Your raw mathematical knowledge has to be transformed into this optimized, step-by-step audit of your logic. The examiners literally want to see your brain working on the page. Just writing down a final correct answer, that might actually score you 0 points if the question specifically says, show that. You are essentially building an airtight legal case for your answer, step by step.
And that brings us to the theoretical architecture you've got to build the second you sit down in that exam hall. Your answers must be firmly rooted in systematic analysis, precise definitions, causal relationships, and rock-solid, evidence-based reasoning. It is definitely not just about randomly dropping equations onto the page and hoping one sticks. Think about it. When you use a double angle formula, say converting sine 2 theta into 2 sine theta cosine theta, you're actively establishing a causal relationship. You're telling the examiner, hey, because of this rule, I can make this solvable. If you skip steps, you break that chain of evidence. And well, that is exactly where your marks just vanish.
Okay, here is the ultimate secret weapon, pulled straight from the principal examiner reports. Cross-topic connections equal higher marks. It's a real game changer. Students who actively integrate double angle formulas with other areas of the syllabus capture significantly higher marking bands. Honestly, it's pretty rare that Cambridge will just hand you a standalone double angle question. They're going to bury it inside an integration problem, or ask you to differentiate a function that you have to simplify first. When you can spot these cross-topic connections on the fly, you instantly elevate yourself into that top percentile.
So the big question is, how do we systematically lock in those method marks when the pressure is on? You need to implement this 5-step procedural framework. Step 1, identify the key elements. Are you looking at a mix of double and single angles? Step 2, apply relevant principles. Ask yourself, okay, which version of the cosine double angle formula is actually going to be useful here? Then step 3 is all about executing your analysis with crystal clear working. Step 4, verify those results. Do your solutions actually fit within the required domain? And finally, step 5, format appropriately. Are we talking radians or degrees here? If you follow this exact sequence, you're never going to leave easy marks on the table again.
But listen, even if you have that perfect logical framework locked in your head, things can still go sideways. We really need to audit the top 3 critical liabilities that cause massive valuation crashes in the exam hall. These are the classic traps that consistently catch students completely off guard year after year, regardless of how well they've memorized their textbooks.
According to the official examiner reports, these 3 specific formatting failures are where candidates just hemorrhage the easiest method marks. Number 1, forgetting the proper format. This usually means panicking and mixing up degrees and radians mid-calculation. We've all been there, right? Number 2, failing to check your overall presentation. If your messy handwriting makes a sign look like a 5, the examiner literally cannot award you points for a brilliant thought process. They just can't. And number 3, providing answers that simply aren't specific to the given context.
Which brings us to a massive examiner alert, the absolute danger of generic answers. Look, if you drop a disconnected formula instead of a tailored, context-specific framework, you instantly lose your competitive edge. Let's ground this in reality. The formula for cosine 2 theta has 3 different variations, right? If the rest of the equation only has sine terms and you blindly write down the version that uses both sine and cosine, all you've proven is that you memorized the textbook. A context-specific, high-scoring answer deliberately chooses the 1 minus 2 sine squared theta version because it creates a solvable quadratic equation. That deliberate choice? That's exactly what earns the big marks.
Now, to really scale your grade up to that A-star bracket, you've got to show top-tier evaluative thinking. That means constantly questioning underlying assumptions, looking at different mathematical perspectives, justifying your decisions with solid evidence, and, crucially, identifying limitations. In trig, this usually comes down to checking your domain. For instance, if you solve a quadratic trig equation and get sine theta equals 0.5 and 2, well, you have to explicitly identify the limitation that sine theta absolutely cannot exceed 1 and then explicitly reject the 2. You have to show the examiner exactly why you're tossing that root out to prove the quality of your reasoning.
Okay, so how do we make sure you don't drop these complex multi-stage steps when the exam clock is ticking and panic sets in? Memory hacks. Actively build a custom mnemonic using the first letters of your key trigonometry terms, or that 5-step framework we just went over. These act as mental anchors. Whether it's a specific acronym to remember the sign of trig functions in different quadrants, or just a quick mental checklist for radians versus degrees, find a mnemonic that specifically targets your personal weak spots in Topic 2.3.
As we wrap up this explainer, I really want to leave you with one pivotal question to ask yourself. Are your unsupported assumptions costing you crucial method marks? Think about it. Every single time you skip a line of working, or you forget to define exactly why you rejected an angle, you were assuming the examiner knows what you mean. Do not leave your final grade to chance. The next time you sit down to hack a past paper, I want you to be explicit, be highly structured, and be incredibly deliberate with every single step. So what unsupported assumption are you going to fix today?